Good evening, my name is Jeffrey Lashley. Today is July 14th, 2024. Make sure the weapon's on safe, make sure the weapon is clear. Checking visually and physically that the chamber is clear, no live ammunition in the area. Weapon on safe, pull the trigger, nothing happens. Put the weapon on fire, pull the trigger, click, charge it, clunk. Okay, that's the disconnector letting go. You can put it on fire, do a drop check, hit the weapon, make sure to do it, hitting the area of the safety to make sure that it doesn't disconnect the hammer. Going to do a dummy round check, do a magazine drop check, works. Cycle of operations. This would make sure that everything closed up and locked up, and then you would be able to fire it on a live fire. But since I'm not doing a live fire, just making sure the magazine locked back to the rear. Whenever you are firing the trigger, you make sure that the trigger is not wobbly and it pulls straight back, and it has the same amount of weight pull each time, approximately 8 pounds. And also always once you let off of that trigger, if the bolt is cycled through, you should feel that clunk. That's it for this week. I'll move on to the next portions of the class. Alright, so we're moving on to the barrel measurement portion. And I don't have any solid tubing for my cleaning. This is what SDI sent me, so this is what I'm going to be using. So basically I'm going to send the rod all the way to the end till it touches the bolt, the face of the bolt, and then I'm going to mark the end of it right here, and then I'm going to pull it out, measure it, and I come up with 18 3/8 of an inch. So our barrel length from the bolt face to the crown is 18 3/8 of an inch. Okay, so next we would check the twist rate, and again I do not have the proper equipment to do so, but I understand the premise behind it. I would take a patch and put it through my eyelet, and I would send this all the way back through. Doing so, then I would take a piece of tape and make a flag. Have it facing up at 12 o'clock position, and then I would have a T-handle that I could pull out and have it turn whenever it was coming out. So first I would mark the position here before I pulled it out. So I pull it till it started engaging the twist, the grooves, and I mark it here. And then as I pull it out, the flag is going to start turning. Like I said, this would be, well, it's actually working on its own without having a handle that turns. So once it goes one full rotation around, right there, I would stop and I would mark here. And this is a 3/08, so this should be 10 inches, one twist for every 10 inches. So I would then measure the marks between these, and based off of that, that was 14 inches. So I will do it again and check it out, but it should have been every 10 inches one twist. So not exact rocket science yet for what I'm learning, but get the premise. All right, I rechecked the twist rate, and it did come out to 10 inches. I just had to kind of finesse it a little bit and pay attention to when it started and also watch how I was pulling it. But I know it would be easier with a rod that has a twirling handle. So next I'm going to check the headspace. I'm going to first put in the go, and I have taken out the extractor. So what I'm looking for is I'm looking for the aft here to be lined up, and it is. So the go is fitting in the datum line. I'm going to take that out, squeeze back around here and force that out. And I'm going to then use the no-go gauge to check it. And I will tell you that I've already checked this, and the no-go gauge also works. Therefore, I know that this has been set to 762. And this is kind of a pain to get out once the extractor's taken off, but that's okay. So next is the no-go. And once the bolt face was set forward, it should not, it actually does line up right there. So again, with the no-go, it's all the way forward, so it works as well. Now if it didn't work, I would check the bolt. I would change out the bolt to make sure that it was not the determining factor, and then if that didn't work, then I would probably determine that the barrel is no good, and it would have to be sent back to the manufacturer or replace the barrel on my own. Okay. All right, next we'll be checking the firing pin protrusion. So we would take our protrusion gauge. I don't know, I'm having a hard time saying that, but we would loosen this up, put this on here, and it pushes this little pin up, and then we tighten this down. And you want to make sure your bolt is all the way pushed down, and your firing pin, which I'm pushing with my pinky up, is pushed all the way up, which then causes this to protrude up. And then you would measure that with calipers, in which I came up with 675 thousandths. And then you measure that against the original, which whenever it's flat, you measure that against that, and I came up with 625 thousandths. So basically 0.05 thousandths difference is what the firing pin, or what the actual protrusion is. So, but that's how you do that. Measure that that way.